In section 11.3, we're talking about sector area and arc length. The area of a sector is a fraction of the circle containing the sector. So let's give you a visual. Just look at this diagram. This is a sector. Now it's a fraction of a circle containing the sector. To find the area of a sector whose central angle measures m degrees, multiply the area of the circle by m divided by 360. So here it is. A sector of a circle is a region that is bounded by two radii and their intercepted arc. So this would be called sector ACB. To find its area, you would take pi r squared multiplied by the angle measure divided by 360. So let's do example 1. Find the area of the sector, give your answer in terms of pi, and round it to the nearest hundredth. We want to know sector MPN. Remember, that's the area. So we would take area equals pi times radius squared multiplied by m degrees divided by 360 degrees. All we do is plug in our values. Pi multiplied by the radius, which is 3 squared, multiplied by 80 degrees divided by 360 degrees. That would be 2 pi squared inches in terms of pi, and rounded to the nearest hundredth would be approximately 6 28 square inches. So there's our first answer. The next one is sector EFG. We just do the same thing. Area equals pi radius squared multiplied by 120 divided by 360. That would give us 12 pi in terms of pi, which is approximately 37.70 centimeters squared, rounded to the nearest hundredth. In example 2, you can just follow along if you'd like, but a circular plot with a 720-foot diameter. Circular plot with a 720-foot diameter is watered by a spray irrigation system. To the nearest square foot, what is the area that the water is sprinkled if the sprinkler rotates through an angle of 50 degrees? So that would be like this, 50 degrees. We plug it in, pi, and radius, well, if 720 is the diameter, well, then the radius would be 360 squared multiplied by 50 degrees divided by 360. Area would be approximately 56,549 square feet. A segment of a circle is a region bounded by an arc and its chord. The shaded region in the figure is a segment. So the area of a segment, here's how we do it. The area of the segment would be the area of the sector minus the area of the triangle. So in example 3, find the area of the segment ACB to the nearest hundredth. So we have to first find the area of the sector. Well, the area of the sector is going to be A equals pi times the radius, which is 12 squared, multiplied by 60 divided by 360, so that'd just be 1/6. And that would give me 24 pi square inches. Now we need to find the area of the triangle. Area of triangle. So we know this is 60. We know this is 12. That's all we know. So we know it's 60 degrees. We need to figure out the altitude. The altitude is going to be what? Well, base we do 1/2 base, which is 12 times the height. If this is the 30, 60, 90 degree triangle, which it is, you know this is 6, so this is going to be 6 root 3. So 6 root 3 will be our height, and the area would be 6 times 6, so 36 root 3 square inches. So now we subtract them. We would take the area of the sector, which is 24 pi, minus 36 root 3, which then rounded to the nearest hundredth would be approximately 13 4/100 square inches. Now, in the same way that the area of a sector is a fraction of the area of the circle, the length of an arc is a fraction of the circumference of the circle. So arc length is the distance along an arc measured in linear units. So if I wanted to find the length, you would take 2 pi r multiplied by the measure divided by 360. So in example 4, our last example, find each arc length. Give your answer in terms of pi and round it to the nearest hundredth. Arc CD, which is this, so that's 90 degrees. You would do L equals the length of the arc equals the circumference, which is 2 pi r, multiplied by the angle measure divided by 360 degrees. That would give me 2 times pi times the radius multiplied by what? Well, this is going to be 90 degrees divided by 360. That gives me 2 times 10, which is 20, times 1/4, which will be 5 pi feet in terms of pi. And 5 times pi would give us approximately 15.71 feet. All right, our next and last example. An arc measure with 35 degrees in a circle with radius 3. So 2 pi times radius 3 multiplied by 35 degrees divided by 360. That would give us 7/12 inches, which is approximately 1.83 inches. And I just realized that there should be a pi here. So 7/12 pi inches. The vocabulary for this section are these 3 vocab words.